going on, guys? Here to give you some guidance in our experiment design sheet. Taking a break from slapping the chat so that I could do my job and help you guys. All right. So first experiment example. Shooting, say, spraying a water hose. Spraying a water hose. What angle would you achieve maximum range? Okay, so what two things would you measure if you're trying to figure that out? Well, you're trying to figure out the maximum distance, okay, you could achieve given a particular angle, right? Or at what angle do you achieve maximum distance? I mean, how many times can I say it? So one of the variables is, of course, angle, right? And the other is distance. The more sciencey term for it is range in this context. So angle and range, and you are changing the angle and seeing how much range you get out of it. So angle then is the independent because that's the variable that you're manipulating or changing. And range, how far the water goes, depends on the angle. Okay, so range is the dependent, angle is the independent. So what else would you hold constant? This is like the example I believe I talked about with like the effect of sleep on performance. What other variables do you need to hold constant so that they don't have influence your results? And we talked about like the food that you eat, or in the context of sports, like the equipment you're using, the weather, those can affect your performance, but that's not what you're testing. So you need to hold that constant and isolate the one variable that you are testing, which in that case is sleep. Okay, so what other variables you hold in constant so they don't affect the range? Well, if you're trying to test like angle, the effect of angle on range, what if like as you're changing angles, you're also the water pressure is also changing. So like, let's say you end up going past 45 and next thing you're like at near 90 degrees, but the water pressure just skyrockets. You might actually get a farther range. And so you might be like, well, there's this magical upper angle, which range is actually is maximum. But that's not actually the case. It was probably the water pressure that did it. So to be sure that it's the angle that's responsible for the range, you need to isolate other variables such as like water pressure. All right. Let's see. I mean, what else could we? Some other people were saying like wind. Like if you have wind, if you're changing the angle and then you get a strong gust of wind blowing against the water, it will actually shorten the range. Or if it blows with the water, it will actually lengthen it. So you have to try and collect data only when the wind is blowing the same way. Okay, because wind is fine. And then other people have said things like the type of hose that you're using, which kind of could probably affect the water pressure. So it's fine. Type of hose. Check out what other people have in your other tabs. Yeah, click across the tabs, see what other people have that's different from what you have. All right. So how would you collect relevant data with the experiment? List the steps of your procedure. People were putting stuff like, test different angles. Okay. All right. Something like that. We get it. Sure. That's what you're trying to do. But imagine this as like literally a procedure that you're writing. Remember, we're trying to do away with me, the teacher, or the textbook company handing you the procedure for an investigation. I want to give you guys practice and opportunity to design a procedure of your own investigation. So what would those steps be? All right. So an appropriate place to start, I mean, we could skip past like the gather materials at this point for this little example. We could at least say it'd be nice to include in the procedure, like mention the limitation or holding constant of these variables. For instance, like for all trials, use the same hose, maintain the same water pressure as well as you can, and collect data only when the wind is blowing in the same direction at the same speed. Okay, sure, fine. That's fine for step one. Step two, choose an angle to start at. You could even suggest a specific angle. So, because really, technically, if you don't offer angle increments, there are infinite angles to test. So, set the hose angle at 10 degrees. Oops. Then you could say, like, go in increments of 5. Okay, why not 10? Well, there's a magic angle that is between 40 and 50 that you want to make sure you collect data for. So set the hose angle at 10 degrees. All right. Spray the hose and record the range. Set the hose angle at its next angle at 15 degrees. How many steps? Oh, geez. I should have put more spaces down. All right, more rows. Set the hose angle at 15 degrees. Spray the hose and record range. All right. Continue with this procedure, increasing the hose angle in 5-degree increments all the way up to 90 degrees. You definitely want to have the person spraying the hose straight up so that they get blasted with water. All the way up to 90 degrees, and recording the range for each trial. Yes! All right. How would you analyze the data? How would you make, would you make a graph? What would you graph? Of course you'd make a graph. Okay, you would graph, well, your two variables. All right, well, otherwise, why did you collect data for them? Why did you measure them? Angle and range. Okay. What would be on your x-axis? Well, the x-axis is your independent variable. Okay, y-axis is your dependent. Okay, there are a few exceptions to that. We'll get to them later, and I'll explain the reason why you sometimes you have to flip them. But typically, independent is on your x. So our independent is, what's our independent variable? Yes! Angle goes on the x. Ooh. What's our dependent variable, which goes on the y? Yes! Range. Okay. Ooh, that conditionally formatted. This one should be whatever. All right. How would you form a conclusion? Oh gosh, I'm almost out of time. How would you form a conclusion? What do you look for data to answer your question? You're looking for the angle at which you achieve maximum range value. Cool. It's a wrap. Come